On September 21st, 1938, an unrelenting force of nature tore through New England, leaving an indelible mark on the region's history. The Great New England Hurricane, later nicknamed the Long Island Express due to its swift and unexpected arrival, became one of the most devastating natural disasters to ever strike the northeastern United States. In a matter of hours, it claimed the lives of over 600 people, caused injuries to thousands more, and left countless communities utterly unrecognizable. The storm's ferocity was unmatched. It first formed as a tropical wave off the coast of Africa, traveling across the Atlantic Ocean, where warm waters fueled its growth into a formidable hurricane. By the time it reached the southeastern United States, meteorologists had grossly underestimated its trajectory. Believing it would veer out to sea, little warning was given to residents along the northeastern coast. In truth, the hurricane was barreling straight for New England at an alarming speed of nearly 70 miles per hour, faster than any hurricane previously recorded. New England was particularly vulnerable to such an event. At the time, weather forecasting was rudimentary at best. The region lacked the satellite technology and sophisticated warning systems we take for granted today. This left residents unaware of the magnitude of the storm, many continuing their daily routines as disaster approached. Adding to this, the infrastructure was ill-prepared for such an assault. Homes, businesses, and roads were constructed without consideration for hurricane-strength winds or catastrophic flooding. The context in which the storm arrived made its impact even more harrowing. The late 1930s were marked by economic strife. As the Great Depression lingered on, many communities were still reeling from the historic floods of 1936, which had decimated homes and livelihoods across the region. For families struggling to rebuild, the 1938 hurricane was not just a natural disaster, it was an unimaginable blow to their chances of recovery. The storm brought a unique and destructive element rarely seen in the region, a storm surge of unparalleled force. As it made landfall on Long Island and moved northward, it pushed an enormous wall of water into coastal communities. Towns like Westerly, Rhode Island, and New London, Connecticut, were among the first to experience the storm's wrath. The surge obliterated homes, docks, and entire neighborhoods, leaving survivors clinging to rooftops or swept away entirely. This was just the beginning. The storm's devastation would stretch far beyond these first few hours, spreading across New England with unimaginable speed and ferocity. As the Great New England Hurricane made its approach, the region's unpreparedness set the stage for disaster. By mid-morning on September 21, 1938, dark clouds began to gather along the southern New England coastline, and the winds picked up with unnerving speed. Yet few recognized the signs of the impending catastrophe. This was a time before widespread hurricane education. Many residents assumed such storms couldn't reach the northeastern United States with significant force. What followed was a tragedy of staggering proportions. When the storm made landfall on Long Island shortly after noon, it unleashed winds of over 120 miles per hour, with gusts exceeding 150 miles per hour. Buildings were torn apart as if made of paper, and trees, some centuries old, were uprooted in seconds. Entire forests were leveled, and the sound of snapping trunks and howling winds created an eerie soundtrack to the devastation. By the time the storm crossed the Long Island Sound and struck southern New England, it had evolved into a once-in-a-lifetime meteorological event. The hurricane's speed compounded its destructive power, giving residents little time to react. In the coastal towns of Connecticut, Rhode Island, and Massachusetts, the storm surge surged as high as 17 feet in some areas, inundating homes, businesses, and critical infrastructure. Rivers such as the Connecticut and Merrimack overflowed, spreading the floodwaters far inland. In Providence, Rhode Island, the devastation was particularly severe. Downtown streets became rivers, with floodwaters rising to over 13 feet in some areas. Entire neighborhoods were submerged, and the power grid collapsed, leaving the city in total darkness. Across the state, coastal communities like Narragansett and Westerly bore the brunt of the storm's fury. Stories emerged of residents climbing onto rooftops or clinging to debris to survive. For many, help was simply too far away to arrive in time. Compounding the chaos was the hurricane's unpredictable path. Meteorologists had expected the storm to move out to sea, leading many in northern New England to believe they were safe. Instead, the hurricane made an abrupt turn northward, catching even experienced weather forecasters off guard. This miscalculation allowed false confidence to spread among the population, further delaying evacuation and preparation efforts. As the storm pushed further inland, its reach extended into Vermont, New Hampshire, and parts of Maine, where hurricane-strength winds and heavy rainfall caused rivers to overflow. In Massachusetts, Boston experienced severe flooding and wind damage, though the city was spared the worst of the storm surge. Rural areas, however, were hit hard with barns, silos, and farmhouses destroyed, leaving many families homeless overnight. While the wind and rain were terrifying enough, one of the hurricane's most chilling features was its speed. Moving at an average of 47 miles per hour, it allowed little time for emergency responders or civilians to organize rescue efforts. The storm's ferocity and swiftness left a lasting impression on those who lived through it, a haunting reminder of how unpredictable and deadly nature can be. As the storm's violent core tore through New England, the human toll mounted rapidly. Entire families were caught in the crossfire of relentless winds and rising waters, their lives upended in an instant. Survivors would recount harrowing tales of perseverance in the face of unimaginable odds, stories that revealed both the immense cruelty of the storm and the resilience of those who endured it. In coastal communities, the storm surge proved particularly lethal. In towns like Westerly, Rhode Island, walls of water swept away entire streets, dragging homes, vehicles, and people into the ocean. Families scrambled to higher ground, often taking refuge in attics, only to find themselves trapped as water levels continued to rise. For many, the race to escape became a desperate battle against time. In one chilling account, a man clung to a floating door for hours, battered by debris, until he was eventually rescued by a passing boat. The hurricane's ferocity extended far inland, catching rural residents off guard. In the Connecticut River Valley, farmers faced devastation as barns were flattened, livestock drowned, and crops were obliterated by the torrential rain. Entire communities were left isolated, with roads washed out and bridges destroyed, leaving rescue teams unable to reach those in need. In Vermont and New Hampshire, flash floods turned serene streams into raging torrents, sweeping away anything in their path. The economic toll on New Englanders was catastrophic. Many small business owners lost their livelihoods overnight, with storefronts reduced to rubble or submerged under feet of water. Fishermen, a cornerstone of the region's economy, saw their boats destroyed and harbors rendered unusable. The already fragile economy, still recovering from the Great Depression, was dealt a crushing blow, leaving many families struggling to rebuild without financial resources or government aid. Heroism emerged amid the chaos. In Providence, police officers and firefighters braved the floodwaters to rescue stranded residents, forming human chains to guide people to safety. The U.S. Coast Guard deployed ships and personnel to recover survivors from wreckage-strewn waters, often risking their lives in the process. In smaller communities, neighbors banded together to provide makeshift shelters, share food, and care for the injured. One of the most poignant aspects of the disaster was its impact on children. In New London, Connecticut, a schoolhouse was swept away by the storm surge, trapping students and teachers inside. While many perished, some were saved through daring rescues, leaving behind stories of courage and heartbreak that would be remembered for generations. Parents searched tirelessly for missing children, clinging to hope, despite the overwhelming destruction around them. Even in the face of such devastation, the people of New England displayed remarkable determination. For every account of loss and suffering, there were also stories of survival and solidarity. Families who had lost everything found solace in the kindness of strangers, as communities rallied together to provide food, clothing, and shelter. The storm, while leaving a trail of destruction, also revealed the strength of human connection in times of crisis. As the storm subsided, the true scale of the disaster became evident. The devastation that the 1938 hurricane left in its wake reshaped New England, affecting not only the physical landscape, but also the region's collective psyche. The once familiar towns and cities were now ghostly remnants, their landscapes marred by the ruins of buildings, downed trees, and miles of debris-laden streets. Emergency response teams, local authorities, and volunteers scrambled to provide aid, but the task was daunting. The challenge was not just clearing roads or salvaging belongings, it was piecing together shattered lives. One of the most pressing concerns in the days after the hurricane was ensuring the safety and well-being of survivors. Makeshift shelters sprang up in schools, community centers, and churches. Medical personnel worked tirelessly to treat injuries, ranging from broken bones and deep lacerations to illnesses stemming from contaminated water. The disaster left thousands without homes, forcing many to take refuge in temporary housing while rebuilding efforts began in earnest. Communities, which had been torn apart, began to come together with an incredible display of unity, determined to rebuild their homes and lives. The financial costs of the hurricane were staggering. In the immediate aftermath, Estimates put the total damage at around $400 million, a figure equivalent to several billion dollars today. The storm's economic impact was not limited to property damage. It was felt throughout New England's industries. Fishing, shipping, and trade were particularly hard hit, contributing to the already dire economic climate of the Great Depression. The storm underscored the vulnerability of the region's infrastructure and brought attention to the urgent need for improvements to withstand future catastrophes. This catastrophe ultimately spurred significant changes in how the United States approached weather forecasting and disaster preparedness. The Great New England Hurricane was a wake-up call that underscored the limitations of meteorological technology of the time. Before this event, weather forecasting was rudimentary at best, with limited tools and data for tracking storms. The 1938 hurricane led to advancements in this field, laying the groundwork for modern forecasting. While the storm had taken the country by surprise, it served as a catalyst for improvements such as the establishment of the National Weather Service, which would eventually employ more sophisticated radar systems and computer models to predict the path and intensity of hurricanes with greater accuracy. Infrastructure development was also a significant outcome of the hurricane's aftermath. Coastal areas that had once been vulnerable to the forces of nature saw the construction of seawalls, stronger flood barriers, and improved building codes. These measures were intended to protect both human lives and property from future disasters. The storm left New England with a lasting legacy of resilience, a reminder that in the face of nature's immense power, preparation and unity are the keys to survival. The memory of the 1938 hurricane continues to hold a place in New England's collective consciousness. Annual hurricane preparedness drills, community education, and awareness campaigns have all been influenced by the lessons learned from that fateful September day. Families who lived through it passed down stories of survival and loss, ensuring that the impact of the storm was never forgotten. For generations, the event has been seen as both a tragedy and a triumph of human spirit, a chapter in the history of the region that speaks to the importance of respect for the forces of nature, community solidarity, and the never-ending work of rebuilding and fortifying in the wake of disaster. As we reflect on the legacy of the Great New England Hurricane, it becomes clear that while nature can be merciless, the courage and resilience of those who face such challenges can be inspiring. The storm's wrath might have left deep scars, but the response to it paved the way for a safer, more prepared future. And so this storm is not just a story of loss, it is also a testament to the strength of the people who lived through it and the lessons learned that continue to shape how we prepare for the unexpected. The story of the Mount St. Helens eruption in 1980 is one of nature's most powerful and unforgettable moments. Before it erupted, Mount St. Helens had been a quiet and dormant volcano for over 100 years. But nature had other plans, and in the months leading up to May, the mountain began showing signs that something big was about to happen. The first clues came in the form of unusual seismic activity. Scientists had long known that volcanic eruptions were preceded by earthquakes, but these were no ordinary quakes. Starting in mid-March of 1980, small but increasingly frequent earthquakes began to rattle the ground beneath the mountain. These tremors, while initially subtle, grew stronger and more persistent. By the end of the month, the quakes were being felt by residents living in the nearby towns of Washington state. The tremors were strong enough that people living in the area began to wonder if something more dangerous was at play. In addition to the earthquakes, other signs of volcanic activity became more pronounced. Scientists, including volcanologists at the United States Geological Survey, USGS, began to observe swelling on the mountain's north face. This was an indication that magma was rising beneath the surface, increasing the pressure inside the volcano. This swelling was the result of an accumulation of magma and gas beneath the ground, pushing outward and creating what is known as a bulge. As the weeks progressed, the tension surrounding the mountain grew. Local officials, aware of the growing threat, began evacuating residents from areas closest to the volcano, but the vast majority of people in Washington state had no idea how catastrophic this event would turn out to be. The concern was that Mount St. Helens might be headed toward an eruption, but no one could have anticipated the scale of destruction that was about to unfold. On March 27, the volcano sent a dramatic warning shot. A series of powerful tremors caused a massive landslide on the north face of the mountain, resulting in a mud flow that swept across a 24 square mile area. The eruption of debris and ash was a vivid reminder that Mount St. Helens was waking up, but the worst was still to come. Scientists at the time believed that a major eruption was inevitable, but no one knew exactly when or how catastrophic it would be. These early warnings, however, set off alarms throughout the region, and government officials began preparing for what was to come. Residents living near the volcano grew anxious as they witnessed the increasing seismic activity. In some cases, buildings were damaged from the tremors, and the sky above the mountain was filled with an eerie glow from the increasing number of earthquakes. For weeks, the mountain had been signaling that it was about to burst, but what exactly would happen remained uncertain. People began to evacuate the area in large numbers, unsure if they would ever return home. The stage was set for what would become one of the deadliest and most destructive volcanic eruptions in United States history. As April arrived, the situation became even more serious. Scientists continued to monitor the volcano, and their findings indicated that the threat of a major eruption was becoming more imminent by the day. The frequency of the earthquakes continued to increase, and the bulge on the north face of Mount St. Helens grew larger, a clear sign that magma was continuing to rise. The pressure building inside the volcano was mounting, and every small tremor felt like a reminder that the eruption could come at any moment. During this time, the US government and local authorities took steps to try to mitigate the threat. They declared a state of emergency, and on May 14th, the exclusion zone around Mount St. Helens was expanded, forcing thousands of residents to evacuate. The National Guard was mobilized to assist with evacuation efforts, and the Army Corps of Engineers worked tirelessly to prevent flooding from the nearby rivers. With all this preparation, everyone was holding their breath, waiting for the inevitable. Little did they know that the events of May 18th would change everything, forever. As May approached in 1980, Mount St. Helens continued to show alarming signs that it was ready to erupt. By now, the mountain had become a focal point for scientists, media, and residents alike. For weeks, the volcano had been shaking and groaning, as if awakening from its long slumber, but no one could predict exactly when or how it would erupt. The volcano's internal pressure was steadily increasing, and the landscape around it was beginning to change in dramatic and unexpected ways. The bulge on the north face of the volcano, which had grown steadily since March, became a major point of concern for volcanologists. This bulge, caused by the rising magma beneath the surface, was not only unsettling but also highly unstable. Experts feared that if the pressure within the volcano continued to increase, it could trigger a massive collapse, releasing an explosion of devastating force. The situation was becoming increasingly dire, and the danger was no longer just a possibility, it was becoming an inevitability. In the days leading up to the eruption, seismic activity reached a fever pitch. The quakes were no longer just tremors, they were powerful and violent shakes, rattling buildings and sending shock waves throughout the region. The mountain itself seemed to be trembling with energy, and the ground around it was becoming dangerously unstable. It wasn't just the residents of the nearby towns who felt the impact. These powerful earthquakes were now being felt hundreds of miles away. Amidst this growing unease, scientists were working around the clock to monitor the volcano's every move. Their primary concern was the potential for a lateral blast, a type of eruption where the volcano releases its energy sideways rather than straight up. This was a particularly dangerous scenario because it meant that the explosive force could travel across the surrounding landscape, flattening everything in its path. If this happened, there was little that anyone could do to escape the destruction. By mid-May, the volcano's ominous behavior had prompted officials to take even more drastic action. Evacuations were ramped up, with thousands more people being urged to leave the area. The government implemented roadblocks to prevent anyone from getting too close to the volcano, and the National Guard was deployed to help with evacuation efforts. Yet, despite the growing warnings, there were still some people who were reluctant to leave. Many residents, particularly those who had lived in the shadow of the mountain for years, were hesitant to abandon their homes, convinced that the volcano would not erupt or that the danger was overstated. But for the scientists and emergency responders, the threat was clear. Mount St. Helens was on the brink of a catastrophic event. While the evacuation efforts continued, other precautions were being put in place to mitigate the possible effects of the eruption. The Army Corps of Engineers worked tirelessly to build temporary dams and barriers along the Toutle River, hoping to control any potential flooding caused by the eruption. Flooding was a real concern, as the intense heat of the eruption could melt the snow on the mountain, sending torrents of water, mud, and ash rushing down into the valleys below. It was a race against time, as the threat of an eruption loomed larger with each passing hour. Meanwhile, the growing volcanic activity continued to shake the landscape. Landslides were becoming more frequent, and the slopes of Mount St. Helens were gradually being stripped of trees and vegetation. A few days before the eruption, on May 17th, scientists detected a massive collapse on the volcano's north face, which was followed by an enormous earthquake. This event was the final warning sign that the volcano's pressure was about to reach a breaking point. Everyone knew that it was only a matter of time before Mount St. Helens would unleash its fury. At the same time, the media frenzy surrounding the eruption reached new heights. Journalists from around the world flocked to the area, eager to document the impending disaster. Helicopter footage of the swollen mountain and the surrounding areas began to fill the news broadcasts. People watched with bated breath as scientists, journalists, and emergency workers all braced for the inevitable. In the days before May 18th, some of the most seasoned volcano experts in the world were still unsure about exactly what would happen next. They had studied volcanic eruptions for years, but the potential force of an eruption like the one Mount St. Helens seemed poised to unleash was unprecedented. Would it be a gentle steam release, or would it be a catastrophic explosion that could level everything in its path? Unfortunately, the world would soon find out, but no one could have prepared for the scale of devastation that would follow. The morning of May 18th, 1980, started like any other spring day in the Pacific Northwest, calm, quiet, and deceptively serene. But beneath the surface, Mount St. Helens was preparing to unleash its fury. The seismic activity had been intensifying for weeks, but now it was no longer just a threat. It was an impending catastrophe. The people living in the nearby towns, though aware of the growing danger, had no idea that the eruption would be unlike anything the world had ever seen. At 8:32 a.m., all that changed. The earth beneath Mount St. Helens rumbled and the pressure built to its breaking point. Without warning, the volcano erupted with an explosive force that shook the entire region and could be heard as far as 200 miles away. What followed was not just a typical volcanic eruption, but one of the most violent and devastating explosions in modern history. The eruption began with a massive lateral blast, unlike any eruption ever seen before. The north face of Mount St. Helens, which had been bulging ominously for weeks, collapsed in a massive landslide. This was no ordinary landslide. This was the beginning of a catastrophic release of energy. As the landslide slid down the mountain, it triggered a violent eruption that sent a massive wall of ash, gas, and rock shooting out sideways at speeds of up to 300 miles per hour. The sheer force of the blast flattened everything in its path. Trees were snapped like matchsticks, and entire forests were obliterated across a 230 square mile area. The land was scoured clean, leaving behind a desolate wasteland. The intensity of the explosion was so powerful that it changed the landscape of the area forever. The eruption was followed by a massive ash cloud that rose high into the sky, reaching altitudes of over 80,000 feet, high enough to disrupt air travel across much of the United States. The cloud of ash spread quickly, darkening the skies and blocking out the sun. For those near the volcano, the skies turned an eerie, sulfurous yellow, and the air grew thick with ash, making it difficult to breathe. As the ash began to settle, it became clear just how catastrophic the eruption had been. The initial blast had been just the beginning. Over the course of the next 9 hours, Mount St. Helens continued to erupt, sending more ash and debris into the atmosphere and creating pyroclastic flows, fast-moving avalanches of hot gas, rock, and ash that raced down the mountainside. The eruption's energy was so intense that it was equivalent to the explosive power of 1,600 Hiroshima-sized atomic bombs. As the ash continued to spread across the region, it brought with it darkness and chaos. The thick ash cloud affected not just the local communities, but also areas hundreds of miles away. In Seattle, more than 200 miles to the northwest, the sky darkened to an unnatural twilight, and the air was thick with dust. Roads were covered in ash, and the landscape was completely transformed. The eruption was felt across the western United States, with ash falling as far as Colorado. It was a surreal, apocalyptic scene, one that seemed to stretch on for days. While the eruption raged on, the immediate aftermath was devastating. The shockwave of the explosion reached as far as the nearby towns, and the surrounding area was quickly blanketed in ash. By the time the eruption had subsided, the town of Spirit Lake was unrecognizable. The lake itself had been choked with debris, and entire sections of forest had been obliterated. Rescue efforts became nearly impossible, as the ash created an impenetrable layer over the land, burying roads, homes, and anything else in its wake. Communication lines were severed and the region was cut off from the outside world. The most tragic aspect of the eruption was the loss of life. 57 people were confirmed dead, though many others were feared to have perished in the eruption's wake. Among the casualties were local residents, scientists, and adventurers who had been observing the volcano's activity in the days leading up to the eruption. One of the most notable victims was volcanologist David A. Johnston, who was stationed at an observation post near the mountain. As he communicated with the U.S. Geological Survey, Johnston's final words were chilling. "Vancouver, this is it," before he was tragically killed in the eruption. His death, along with the deaths of many others, was a sobering reminder of the unpredictable and deadly nature of volcanic eruptions. As the ash continued to fall, the volcano's eruption sparked not just widespread destruction, but also a deep sense of awe at the raw power of nature. What had once been a quiet and dormant volcano had now become one of the most violent and destructive natural disasters in history. The eruption of Mount St. Helens had left a lasting scar on the landscape, but it also changed the way scientists would approach volcanic eruptions in the future, and served as a stark reminder of the unpredictable forces at work beneath the Earth's surface. The eruption of Mount St. Helens on May 18, 1980, had forever altered the landscape of Washington state, but the true scale of its aftermath was not fully realized until days, months, and even years later. The immediate devastation left behind was staggering. The once thriving forested areas were now reduced to barren wastelands, stripped of vegetation, wildlife, and the towering trees that had defined the region for centuries. Entire ecosystems were wiped out, and the earth itself was left scarred, as if nature had been reset in an instant. In the wake of the eruption, the human toll was devastating. The loss of 57 lives, many of whom had been in the danger zone despite evacuation orders, was just the beginning of the broader, long-term consequences. Hundreds of homes were destroyed, and entire communities found themselves displaced, with people left to rebuild their lives from the ground up. The destruction of the timber industry alone was a blow to the region's economy, as vast swathes of forest land had been decimated. The ashfall, which had blanketed homes, farms, and businesses for miles, had further disrupted daily life, causing widespread destruction of crops and infrastructure. The environmental impact was also catastrophic. The blast zone, once rich in flora and fauna, was now a vast, lifeless expanse. The loss of vegetation meant that the soil would no longer be able to support agriculture, and it would take years for nature to begin the slow process of recovery. The ecosystems that had existed for centuries were disrupted, and many species of animals, including some native to the area, were forced to adapt or perish. Spirit Lake, a pristine natural wonder that had been a popular recreational spot before the eruption, was severely affected. The massive mud flows, which had poured into the lake during the eruption, raised its water level significantly and caused debris to flood its shores. The once beautiful lake was now clogged with ash, logs, and other debris. The volcanic ash, which had fallen over 11 states, also had a profound impact on both the local and national level. The ash cloud, which reached high into the atmosphere, disrupted air travel, forcing airports to close and delaying flights for days. It was so thick that it caused the sky to turn dark, even in cities far from Mount St. Helens. On the ground, the ash created a choking haze that made it difficult to breathe, with residents wearing masks and trying to protect themselves from inhaling the dangerous particles. The ash also contaminated drinking water supplies, and it took months for affected communities to restore normal services. Many areas had to undergo extensive cleanup efforts as the fine ash found its way into everything: homes, businesses, and even the engines of vehicles, which caused mechanical failures and accidents. The economic effects of the eruption were felt across the Pacific Northwest, especially in the timber industry, which had been one of the region's largest sources of income. With vast tracts of forest destroyed, the timber industry faced significant challenges in its recovery. It would take years to restore even a fraction of the lost forest, and the region's economy was forced to adjust to the new reality of a world without the towering trees that had once stood proudly along the mountainsides. Despite the overwhelming loss and destruction, Mount St. Helens also became a symbol of resilience and renewal. Over time, the area began to recover. Volunteers, scientists, and local communities worked together to rebuild roads, clean up debris, and restore services. Scientists, too, saw the eruption as an opportunity to study the rapid changes to the ecosystem and the rebirth of the land. Over the decades that followed, the landscape slowly began to show signs of life once again, with new plant species growing and animals gradually returning to the region. It became a living laboratory where researchers studied the resilience of nature and the ability of ecosystems to recover from catastrophic events. While the recovery process took years, the eruption also provided vital lessons for the scientific community. The eruption of Mount St. Helens demonstrated the unpredictability of volcanic activity and the importance of monitoring volcanoes closely. The disaster prompted changes in volcanic monitoring methods, as well as improvements in early warning systems for residents living near active volcanoes. The lessons learned from Mount St. Helens helped save countless lives in future eruptions and made the world more prepared for volcanic events. Though Mount St. Helens has slowly healed over time, it remains an enduring reminder of the power of nature and the unpredictable forces that shape our planet. The eruption was a humbling moment in history, one that left scars on the land and the people who witnessed it, but also gave birth to new opportunities for scientific discovery and environmental renewal. The mountain itself stands as a monument to resilience, both human and natural, and serves as a constant reminder that while we can never fully control the forces of nature, we can learn from them, adapt, and rebuild. Lituya Bay, located in the southeastern part of Alaska, may appear to be a quiet, peaceful fjord, but it has a history of terrifying and destructive power that most people don't even know about. On July 9, 1958, Lituya Bay became the site of one of the most shocking natural events ever recorded, a megatsunami that reached a mind-blowing height of 1,720 feet. To put that into perspective, that's taller than the Empire State Building, and no tsunami before or since has ever come close to matching that record. The event began with a massive landslide when an enormous chunk of rock, estimated to be around 30 million cubic yards in size, suddenly plunged into the bay. This was no ordinary landslide. The force of the rocks crashing into the water sent a powerful wave surging up and over the surrounding cliffs, creating a tsunami of catastrophic proportions. The wave tore through the narrow bay at an incredible speed, wiping out everything in its path. It was so powerful that it even stripped trees from the mountainsides, leaving behind a barren landscape where the lush forest had once stood. Despite how incredible and destructive the megatsunami was, there were only a few eyewitnesses. The most well-known of these witnesses were the people aboard the fishing boat, the Lynn, a vessel that was near the bay when the event occurred. The crew of the Lynn had a front row seat to the incredible wave as it hurtled toward the shore. They managed to survive, but the impact of the megatsunami left them in awe of nature's raw power. What happened at Lituya Bay in 1958 raises a lot of questions, some of which still don't have clear answers. How exactly did the landslide happen? Was it purely a natural event, or did human activity, such as logging or other environmental factors, contribute to the disaster? And could something like this happen again? The sheer magnitude of the megatsunami's height and its unexpected nature have led to many speculations and studies over the years, but there's still no concrete understanding of all the factors involved. As scientists continue to study Lituya Bay and its unusual geography, the mystery deepens. The bay is surrounded by steep cliffs that create a narrow, confined space. This trapped environment amplifies the force of natural events, making Lituya Bay a particularly dangerous and unstable place. The landscape, combined with the ongoing tectonic activity in the region, sets the stage for even more potential disasters in the future. Scientists have learned that the same geological forces that caused the megatsunami of 1958 are still at play today, meaning that Lituya Bay's danger has never fully passed. As we move forward, we'll dive deeper into the science behind what happened in 1958 and explore the ongoing risks that this place faces. Stay tuned as we continue this journey through one of the most fascinating and dangerous natural events in history. In order to understand the full scale of the 1958 megatsunami in Lituya Bay, we need to explore the geological forces that made it possible. The event didn't happen randomly. The bay is situated in a region with a unique and volatile combination of factors that make it prone to natural disasters, especially ones as destructive as a megatsunami. Lituya Bay is a narrow fjord, which means it's a body of water surrounded by steep, towering cliffs. The geography here is a major part of what turned a landslide into a record-breaking tsunami. When the rock slide occurred on that fateful day in July, the steep cliffs funneled the massive amount of energy from the falling debris into a concentrated area. This caused the water to rise with such force that the wave reached an unimaginable height. With nowhere for the energy to escape, the force of the water surged upward rather than spreading out over a larger area. It created a tsunami that was much more powerful than what you'd typically see in the open ocean, but what made this particular landslide so massive? For starters, the region around Lituya Bay is incredibly seismically active. The Pacific and North American tectonic plates are constantly shifting, and the pressure between them builds up over time. This ongoing movement of the Earth's crust can trigger massive earthquakes, which in turn can cause landslides. In fact, it's believed that the landslide that triggered the megatsunami was caused by a relatively small earthquake, measuring about 7.8 on the Richter scale. While not a huge earthquake by some standards, it was enough to send tons of rock crashing into the bay. The landslide itself wasn't just a random event, it was part of the complex natural forces that had been at play in the region for thousands of years. The bay's geological history is filled with tectonic activity, and its physical structure makes it prone to events like this. With steep cliffs and a narrow channel, the water in Lituya Bay is essentially trapped in a confined space. When something like a landslide occurs, the water doesn't have much room to spread out, and it ends up pushing straight up and over the cliffs, creating a catastrophic wave. Adding to the danger of the bay is the region's high level of seismic activity. Earthquakes are a regular occurrence, and while most are small, larger ones can trigger events like the landslide that led to the megatsunami. The energy released from these earthquakes can shake loose unstable rock formations, triggering massive rock slides into the bay. This, combined with the topography of the bay itself, creates a perfect storm for disaster. Understanding the geological makeup of Lituya Bay helps explain why this megatsunami was so devastating, but it also raises important questions about future events. The forces at work here haven't gone away. In fact, they're still very much present. The same tectonic activity that triggered the 1958 disaster could cause similar events to occur again. With ongoing seismic activity in the region, Lituya Bay remains a place of concern for scientists studying the area. As we move on, we'll look at the aftermath of the megatsunami and how scientists have studied its effects. Despite its terrifying nature, this event has provided valuable insights into the power of natural disasters and the ways we can better understand and prepare for them in the future. The aftermath of the 1958 Lituya Bay Megatsunami was both stunning and sobering. The destructive wave, which reached an unimaginable height of 1,720 feet, left an indelible mark on the landscape and offered valuable insights into the forces that shape our planet. In the hours and days following the disaster, scientists and survivors began to grasp the full scope of the devastation. The most immediate and visible effect of the megatsunami was the widespread destruction of the surrounding forest. As the wave surged up the cliffs and crashed into the mountains, it stripped trees from the slopes, leaving behind a barren and eerie landscape. The water's sheer force was so great that it uprooted massive trees and left them scattered across the bay, some of them still floating in the water long after the event. The power of the wave was undeniable, and its impact on the environment was clear. Not only were trees destroyed, but the wave also caused significant erosion along the cliffs, leaving scars on the land that are still visible today. Remarkably, the megatsunami's effects were not limited to just the surrounding environment. The local population, who lived in small villages near the bay, were lucky to escape the full force of the disaster. While there were no fatalities directly linked to the megatsunami itself, the event did cause major disruptions to local communities. The destruction of land and wildlife affected the livelihoods of those who depended on the region's natural resources for survival. Despite the isolated nature of the bay, the force of the event was felt across the surrounding area, and the cleanup and recovery process was long and difficult. One of the most fascinating aspects of the 1958 megatsunami is the fact that only a few people witnessed the event firsthand. A small number of boats were in the bay at the time, and while most were able to escape the brunt of the wave, one fisherman and his family were in a boat near the shoreline when the wave struck. Their accounts provide an eerie glimpse into the terrifying power of the disaster. As the wave hit, the water in the bay suddenly surged, and they reported seeing the mountain cliffs on either side of them disappear into a wall of water. The fisherman and his family were lucky to survive, but their experience is a vivid reminder of the destructive potential of such an event. The scientific community was quick to respond to the megatsunami, conducting studies to understand its full scope and the forces that made it possible. Researchers used a combination of eyewitness accounts, geological surveys, and data from nearby seismic stations to piece together the puzzle of what had happened. What they discovered was a rare and unusual event that, while not common, could potentially happen again. The Megatsunami in Lituya Bay was not just a freak accident, but rather a reminder of the raw power that exists in Earth's geological processes. As researchers began to analyze the event, they realized that the Lituya Bay Megatsunami was unique, not only because of its extreme height, but also because of the specific conditions that made it possible. It was the perfect storm of seismic activity, topography, and geology that resulted in the massive wave. In a way, the disaster offered a rare opportunity for scientists to study how large-scale landslides and earthquakes can create such intense tsunamis, something they may not have been able to study under normal circumstances. Looking forward, scientists began to consider what the future might hold for Lituya Bay. While the region's seismic activity had been relatively stable in the years since the 1958 megatsunami, the underlying geological factors that caused the disaster are still very much in play. The Pacific and North American tectonic plates continue to shift, and the possibility of another landslide or earthquake remains a real threat. But what makes Lituya Bay particularly dangerous is its location and its ability to amplify the effects of such events. The bay's narrow, enclosed shape funnels the energy of any seismic or landslide event directly into the water, making it a potential breeding ground for another megatsunami. As we move forward in this story, it's important to consider how the Lituya Bay Megatsunami has shaped our understanding of natural disasters and the science behind them. The lessons learned from this event continue to inform the ways we study and prepare for similar events in the future, highlighting the need for more research into the dynamics of earthquakes, landslides, and tsunamis. The events of July 9th, 1958 may be long behind us, but the lessons they left us with are still very much relevant today. As we reach the conclusion of the Lituya Bay Megatsunami story, it's important to reflect on the lasting impact the event has had on both scientific research in the local area. The 1958 megatsunami was a game changer for the way we understand the power of nature and the destructive potential of tsunamis. Despite the rare and isolated circumstances of this event, it has sparked ongoing investigations into similar areas around the world, all of which have the potential to experience a similar catastrophe. One of the most significant consequences of the megatsunami was the heightened awareness it brought to the vulnerability of coastal areas that are situated near active geological zones. As a result, scientists began to study how earthquakes and landslides could trigger tsunamis in other regions with similar topographical and seismic conditions. While Lituya Bay is an extreme case, the principles of how it all unfolded have been applied to better understand tsunamis in general, especially those that might occur along the Pacific Ring of Fire, where tectonic activity is high. Although there were no fatalities directly linked to the megatsunami, the disaster highlighted the importance of early warning systems and preparedness in regions at risk for tsunamis. The speed at which the waves surged through Lituya Bay left little time for people to respond, making it clear that places with a history of seismic activity need to be on high alert. In the years following the event, efforts to improve tsunami warning systems became a priority for many coastal regions around the world. Scientists also started to look more closely at the effects of large landslides and how they could trigger waves, a crucial element in preventing or mitigating future disasters. The unique and isolated geography of Lituya Bay has also made it a focal point for geological studies. Researchers continue to study the bay and its surroundings to this day, gathering data on its ongoing seismic activity and the state of its landscape. The potential for another major landslide or earthquake is still very much a possibility, and while it may be impossible to predict exactly when or where the next catastrophic event will strike, the lessons learned from the 1958 megatsunami have paved the way for better preparedness and understanding of similar events elsewhere. What is perhaps most striking about the Lituya Bay Megatsunami is the sheer power of nature. It serves as a reminder that even in the most peaceful and remote locations, the Earth's forces are always at work, shaping and reshaping the landscape in ways we can't always predict. This disaster may have been an extreme and rare event, but it's one that serves as a warning that nothing on Earth is immune from the power of natural forces. In the years since the disaster, the memory of the megatsunami has lingered, both in the scientific community and in the local memory. It stands as a testament to nature's ability to surprise us and remind us of how little control we truly have over the forces that shape our world. Lituya Bay may seem quiet and peaceful today, but it still holds the potential for the kind of sudden, devastating event that forever alters the landscape. As we finish reflecting on the events of July 9th, 1958, it's clear that Lituya Bay continues to be a unique geological and environmental location that holds important lessons for all of us. It's a reminder that while we may not be able to control or fully predict these catastrophic events, understanding and respecting the natural world around us is essential for surviving and navigating the unpredictability of life on Earth. And who knows, perhaps one day scientists will uncover even more secrets hidden in the depths of Lituya Bay. Until then, we continue to study, learn, and prepare, taking the lessons of the past to better understand the future. California is no stranger to wildfires. For decades, the state has battled these devastating blazes, but in recent years, the frequency and intensity of the wildfires have reached terrifying new levels. Wildfires are now a regular part of life in California, and the danger continues to grow. In fact, some of the worst fires in California's history have occurred just in the past few years. And it's not just the scale of the fires that's concerning, it's the fact that they seem to be getting worse, faster, and more unpredictable. Wildfires have always been a part of California's natural landscape, but the fires of today are different. The combination of extreme heat, persistent drought conditions, and changing weather patterns has created a perfect storm for these wildfires to spread uncontrollably. In 2023 alone, thousands of acres of land burned across the state, causing widespread damage and destruction. It's a growing crisis that's forcing entire communities to evacuate and is leaving families to pick up the pieces of their shattered lives. Let's break down some of the staggering numbers. In recent years, the state has experienced some of the largest wildfires in its history. Just in 2018, the Camp Fire alone destroyed over 14,000 homes and claimed the lives of 85 people. It was the deadliest wildfire in California's history. Then in 2020, the August Complex Fire became the largest wildfire the state had ever seen, burning over 1 million acres of land. Entire towns were leveled, and the devastation was unlike anything we had seen before. The immediate destruction caused by these fires is overwhelming, but the long-term effects are just as alarming. Not only are these fires taking a massive toll on human life and property, but they're also severely impacting California's environment. Wildfires destroy thousands of acres of forests, habitats, and natural landscapes. With millions of acres of land already scorched, the question is, how much more will burn before we see change? But the problem doesn't end with the destruction of the land. The economic cost is also staggering. Wildfires in California have caused billions of dollars in damages, far more than most people realize. From agricultural losses to businesses forced to close, the financial impact ripples through the economy in ways that aren't immediately visible. The losses affect entire industries, from the wine-growing regions in Napa Valley to small towns in the foothills. And let's not forget the cost of rebuilding, which can take years or even decades, with communities often facing months or years without proper housing. While the numbers are staggering, it's essential to remember that wildfires don't just impact the environment or the economy, they impact real people. These fires change lives in ways that can never be fully measured. Families lose homes, loved ones, and entire communities are uprooted. Survivors are left dealing with the emotional and psychological trauma of having their lives turned upside down. The impact on mental health is profound, and it can last long after the flames have been extinguished. The fear of the unknown, the anxiety of evacuation, and the devastation of loss weigh heavily on those who experience it. As we look at this growing crisis, it's clear that California's wildfire epidemic is not just a seasonal issue. It's a part of a much larger and more complex set of challenges. The fires of today are linked to the changing climate, poor land management practices, and our own human activities. Each fire is a warning sign that we need to take action. The question is, how do we respond before it's too late? As we continue, we'll take a deeper look into what exactly is driving the spread of these fires, and what factors are making California's wildfires worse than ever before. Stay tuned to learn more about the causes behind this devastating crisis. The causes of California's wildfire epidemic are multifaceted, and understanding what's behind the intensity and frequency of these fires is crucial if we are to have any hope of controlling them. While wildfires have always been a natural part of California's landscape, several key factors are making these fires more dangerous and harder to fight. One of the primary drivers of this crisis is climate change. As the Earth's temperatures continue to rise, California is experiencing longer, hotter summers and more intense heat waves. Over the past few decades, temperatures have steadily increased, leading to conditions where wildfires can thrive. The combination of higher temperatures and drier weather means that forests and grasslands are more prone to ignition. California's climate is naturally dry in many regions, but with climate change accelerating these conditions, fire seasons are starting earlier and lasting longer. Rising temperatures also contribute to the drying out of vegetation, creating more fuel for wildfires to feed on. This year, for example, California saw record-breaking temperatures in some areas, pushing the limits of the state's fire management strategies. The hotter it gets, the faster the fires spread, with flames consuming everything in their path. Another significant factor is the changing precipitation patterns. California has long been affected by droughts, but these conditions are becoming more severe. Droughts dry up rivers, lakes, and water supplies, and they also dehydrate plants, making them more susceptible to fire. The state has experienced extreme drought years in the past, but in recent years, these droughts have been more intense and longer lasting. Climate change has disrupted the natural water cycle, making it harder to predict when these dry spells will end, leaving California's landscapes more vulnerable to fire. But it's not just the weather. Poor forest management practices have also contributed to the severity of these fires. In the past, controlled burns and other fire management practices helped to clear dry vegetation and prevent catastrophic fires. However, these practices have not been consistently implemented over the years. As a result, forests have become overgrown with vegetation, creating more fuel for fires to spread rapidly. The dense underbrush and dead trees in California's forests have created a perfect environment for massive fires to take hold and become uncontrollable. Another significant factor is human activity. While many wildfires are sparked by natural causes like lightning strikes, a large portion of California's wildfires can be traced back to human actions. In recent years, careless behavior has caused several deadly blazes. For instance, campfires that aren't fully extinguished, discarded cigarettes, or even sparks from vehicles on dry roads have started fires that quickly spiraled out of control. Arson is also a growing problem, with individuals intentionally setting fires for a variety of reasons, sometimes out of malice or for financial gain. These intentional fires are often the hardest to contain and can lead to widespread destruction, as seen in the past with large-scale fires like the Thomas Fire in 2017 and the Kincaid Fire in 2019. The combination of drought, overgrown forests, extreme temperatures, and human activities has created a volatile situation. Each of these factors on its own is concerning, but when they all come together, the results can be catastrophic. Add in the fact that California's population continues to grow, and more people are living in high-risk fire zones, and it's clear that this crisis is not going to get better without significant changes in policy, fire management, and our collective behavior. What's even more alarming is that we are seeing wildfires spread more quickly and more destructively than ever before. The fires of recent years have torn through entire towns, leaving communities with little warning to evacuate. The Butte Fire in 2015 and the Camp Fire in 2018 both highlighted how fast and unpredictable these fires can be. Entire neighborhoods have been wiped off the map, and people have had to abandon their homes and their lives in the face of this growing inferno. In some cases, these fires have moved so quickly that people only had minutes to escape. With no time to grab personal belongings or say goodbye to their homes, the damage caused by these fires is beyond just the immediate destruction. Wildfires release huge amounts of carbon dioxide into the atmosphere, worsening global warming and creating a vicious cycle. The destruction of natural habitats also disrupts ecosystems, forcing animals to flee and sometimes leaving them without food or shelter. This ecological damage can take years or even decades to recover, with some species losing critical habitats forever. In the next part, we will take a closer look at some of the most devastating fires in recent history and the aftermath they left behind. These stories highlight the urgency of addressing the wildfire crisis and the profound impact it has on individuals, families, and entire communities. Stay tuned as we dive deeper into the aftermath of California's raging fires. As the fires rage across California, it's not just the flames that leave lasting damage, it's the aftermath. The toll of these wildfires on people's lives, the economy, and the environment is immense and often irreversible. While the flames themselves are terrifying, the emotional and long-term consequences of losing homes, loved ones, and communities can be just as devastating. One of the most striking consequences of California's wildfire crisis is the human impact. Thousands of families have been displaced with no place to call home. When fires like the Camp Fire in 2018 hit, entire neighborhoods were destroyed. For the people of Paradise, California, the devastation was particularly heartbreaking. The Camp Fire was the deadliest wildfire in the state's history, claiming the lives of 85 people and reducing the town of Paradise to rubble. The survivors were left not only with the loss of their homes, but also the loss of their community and support systems. In the immediate aftermath of such catastrophic events, people are forced to leave behind their memories, their homes, and their lives as they knew them. The psychological toll of losing everything in a fire is staggering. The trauma of evacuation, the uncertainty of what the future holds, and the constant fear of more fires create a psychological burden that lingers long after the flames are out. The process of rebuilding isn't just about physical structures. It's about repairing the emotional wounds of people who've lost everything. Moreover, the economic impact of these wildfires is crushing. In addition to the physical destruction of homes and businesses, wildfires also disrupt entire industries, costing billions of dollars in damages. Agriculture, which is a key part of California's economy, is particularly vulnerable. Fires destroy crops, disrupt the harvest season, and damage irrigation systems, leading to massive financial losses. In the wine country of Napa Valley, for example, fires like the Tubbs. Fire in 2017 not only destroyed homes, but also devastated vineyards, causing long-term financial damage to the region. Businesses in affected areas face steep challenges in recovering. Many are forced to close their doors permanently, while others struggle to reopen, burdened with costly repairs, lost customers, and ongoing health and safety risks. With fires becoming more frequent and severe, it's increasingly difficult for communities to recover fully. The damage is not only financial, but also emotional, as people are forced to leave behind the places they've built their lives. The environmental consequences of wildfires are just as severe. When wildfires burn, they do more than destroy homes and infrastructure. They also damage ecosystems that may never fully recover. Wildfires release large amounts of carbon dioxide into the atmosphere, which contributes to global warming. In fact, in some extreme cases, a single wildfire can produce more carbon emissions than an entire country's annual output. The wildfire season is now a major contributor to California's carbon footprint, exacerbating the very climate conditions that fueled the fire in the first place. Furthermore, wildfires have a profound effect on local wildlife. As fires tear through forests and grasslands, they destroy animal habitats, displacing or killing countless creatures. The Sierra Nevada region, home to rare species like the Sierra Nevada bighorn sheep, is particularly vulnerable. These animals rely on the forests for shelter, food, and breeding grounds. When their habitats are destroyed by fires, their survival is put at risk. Some species may be pushed to the brink of extinction as their natural homes disappear. The loss of vegetation and trees also leads to soil erosion, which can further damage the landscape. Without trees to anchor the soil, the ground becomes loose and more prone to erosion. Especially after rain, this can lead to devastating mudslides, which can flood already vulnerable areas, making recovery even harder. The fire-ravaged hills of California are at particular risk, as fire scars create conditions where heavy rains can lead to mud flows that destroy homes, roads, and vital infrastructure. Water quality is also threatened by wildfires. As fire destroys the land, the ash and debris flow into rivers and streams, contaminating water supplies. This can affect everything from drinking water to agricultural irrigation. The long-term environmental damage caused by these fires can take years to reverse, and some areas may never fully recover. Wildfires also disrupt wildlife migration and force animals to flee to other areas, putting pressure on ecosystems that are already under strain. These environmental impacts are not just immediate, they affect California's future. As wildfires become more frequent, it's clear that the state's ecosystems will continue to bear the brunt of the destruction. Rebuilding these areas, both ecologically and economically, will be a long and difficult process. Next, we will explore the efforts being made to tackle California's wildfire crisis. From firefighting strategies to climate policy, we'll take a closer look at the steps being taken to address this urgent issue. California's wildfire crisis is an urgent challenge, but it's not without efforts to fight back. While the fires continue to ravage communities, resources and strategies are being deployed to reduce the frequency, severity, and damage of these catastrophic events. The problem is complex, but there are critical steps being taken to address the situation from multiple angles, including fire prevention, firefighting, and long-term policy changes. One major area of focus is fire prevention. In the past, California's fire strategy primarily focused on firefighting efforts once fires had already started. However, experts have increasingly emphasized the importance of preventing fires before they spread out of control. Controlled burns, or prescribed burns, are one of the most effective tools in reducing wildfire risk. These burns are intentionally set under controlled conditions to reduce the amount of fuel, such as dry brush, that could contribute to a larger, more dangerous fire. Although controlled burns have been used for centuries, their implementation has been inconsistent, and many experts argue that more extensive and frequent use of this technique is crucial. Alongside this, forest management practices have been reevaluated. California's forests have suffered from decades of neglect and poor management, leading to overgrown trees, dead vegetation, and dry conditions. By thinning out dense forests, removing dead trees, and restoring healthy ecosystems, the risk of large uncontrollable fires can be reduced. In recent years, both the state and federal governments have begun investing in forest restoration projects, but much more needs to be done to manage the millions of acres of land that are at risk. A critical aspect of California's wildfire response is the firefighting efforts. The state has a robust network of firefighters, both professional and volunteer, who fight fires on the front lines. However, the increasing intensity and frequency of fires in recent years has stretched these resources to the limit. In response, California has been increasing its investment in firefighting technology, from aerial firefighting units such as helicopters and planes to more advanced fire suppression systems. These air resources can drop water or fire retardant to slow the fire's spread and give ground crews more time to control the flames. Additionally, California has also sought to improve its firefighting coordination. Wildfires don't respect state lines, and in many cases, fires have spread across counties and even into neighboring states. By improving communication and collaboration between local, state, and federal agencies, response times can be faster and more resources can be allocated to areas in desperate need. This coordination extends to mutual aid agreements, which allow fire departments from different areas to assist each other during major disasters. Technology has become a vital tool in California's battle against wildfires. Innovations like drones, satellite imagery, and artificial intelligence have been used to detect fires early, monitor fire behavior, and predict how fires will spread. The use of real-time data helps firefighters make better decisions on where to focus their efforts and how to protect lives and property. In particular, early warning systems have been improved, allowing residents to receive evacuation notices and alerts sooner. The state has also invested in fire mapping tools to predict where fires are most likely to strike, based on weather patterns, land conditions, and past fire history. Climate change mitigation also plays a major role in California's efforts to curb the wildfire crisis. As we've seen, rising temperatures, prolonged droughts, and changing weather patterns have created the perfect conditions for wildfires. To combat this, the state has made significant strides toward reducing greenhouse gas emissions and transitioning to renewable energy sources. California's climate change policies include goals to achieve carbon neutrality by 2050 and increase the use of clean energy across the state. By addressing the root cause of changing weather conditions, California aims to reduce the frequency of extreme conditions that contribute to wildfires. Community preparedness is another key component of the state's strategy. California has ramped up efforts to educate the public about fire safety, evacuation plans, and the importance of creating defensible spaces around homes. Fire-resistant materials and building codes are also being updated to ensure new construction is more resilient to fires. In some areas, fire-resistant landscaping and the clearing of dead vegetation around properties are now mandatory to reduce the risk of fires spreading to homes. Despite all of these efforts, it's clear that California cannot solve this crisis overnight. Long-term recovery and preparation are essential. Rebuilding communities after fires is a lengthy process, and there's still much work to do in terms of restoring habitats, ecosystems, and the mental well-being of those who've lost so much. Moreover, the constant threat of future wildfires looms large. California must remain vigilant, adaptive, and proactive in its approach. However, there is hope. Communities in fire-ravaged areas are coming together to rebuild, stronger than before. There's a growing recognition that while wildfires will continue to be a part of California's landscape, we can reduce their impact and ultimately learn to live with them. By combining fire prevention, smarter forest management, improved firefighting efforts, climate change mitigation, and community preparedness, California can move toward a safer, more resilient future. This crisis is a reminder of how fragile our environment is and how important it is to take action. The wildfires of the last few years have shown us the devastating effects of climate change and poor management, but they've also highlighted the incredible strength and resilience of the people of California. The battle against wildfires is ongoing, but with continued effort and innovation, there is hope for a future where California's wildfires become less destructive and the communities they threaten can thrive once again. Thanks for watching. Let's continue this conversation. If you have thoughts on California's wildfire crisis, feel free to share them in the comments. And don't forget to subscribe for more discussions on environmental challenges and their impacts on our world. Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set, and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through through valleys and waterways. One of the most notable impacts was at the Drift River Terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reached those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the costs of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska, but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world.